For most of the history of Microsoft development technologies, database application developers have had to work with data outside of the programming language of choice, whether it's VB or C#, C++, or almost anything else. Either you had to embed dynamic SQL into an application or write stored procedures using T-SQL. And SQL is a very different language from the .NET languages. The result is that at compile time, the language compiler has no information about your data and may compile the application, but the application may not run because of problems with the data access code. You could have an invalid connection string, an incorrect assumption about the relations between tables, or myriad other problems that the compiler can't catch. And the situation forces the developer to learn both the programming language and the database language, which is usually SQL. Entity Framework's object relational mapping provides a mapping between relational data and objects, and a cleaner integration of business rules and validation than what has been available as part of ADO.NET. But the entity data objects it produces don't provide querying features, and historically, the .NET languages have not directly provided support for directly querying databases. The one exception is in Microsoft's product lineup has been Visual FoxPro, which was originally based on Ashton Tate's DBase products. Unfortunately, Microsoft long ago decided to stop all forward development on FoxPro, so it's no longer a viable option for new development. So Microsoft's answer to this disconnect between its .NET programming languages and data access code has been LINQ, which stands for Language Integrated Query, and it was introduced in version 3.5 of the .NET framework. The integrated part of LINQ means that it's built into the language syntax of both Visual Basic and C# that makes querying data a core programming concept that's part of the language itself. LINQ works with all kinds of data, including relational databases, XML, and plain objects. Because it's a language feature as opposed to a Visual Studio Designer feature, LINQ works in any kind of project, including Windows and web projects. With LINQ, you can write your data access code directly in your programming language of choice. This way you get compile time syntax and schema checking as well as IntelliSense. There's no need to provide connection strings or field names as strings, both of which make it impossible to verify your code at compile time. Instead, LINQ provides these items as part of the language. The LINQ data access code is abstracted from the underlying data, so you can use a consistent syntax across various data sources and can join data from different sources. Depending on the underlying data source, LINQ comes in several variants, including LINQ to SQL, LINQ to relational data, and LINQ to XML, as one for the entity framework, LINQ to entities. All the LINQ variants have language features in common, as well as additional features that support special features of whatever underlying data source that you're using. Both Visual Basic and C# support two forms of LINQ syntax: query expressions and methods. Query expressions use kind of a SQL-like syntax. You won't mistake it for SQL, but it has the same keyword, so it looks kind of similar. Right? Because it's basically a turned around form of SQL in order to form queries as regular language statements. And then LINQ methods use method chaining on objects that's a bit more like how you program with objects in .NET languages. So let's take a brief look at these two different forms of LINQ. The first one is LINQ query expressions. If you're used to the SQL language of relational database engines, the LINQ query expression syntax will probably be fairly familiar. So here's a simple expression that retrieves all of the customers with the first name of Anne in the AdventureWorks LT database. So it says from C in customers where C.firstname equals Anne, and then you select C. The C variable in the statement is just an arbitrary variable name that references the object that you want to work within the query, and it's called a control variable. So where I say from C in the query, I can reference the properties of each customer object retrieved from the data store, such as to use the first name property to filter the customers that you want from the query, and that's what's happening within the statement. All right, and then here is the equivalent SQL statement. Select star from sales LT customer where first name equals Ann. Now I use select star there. It's a bit of a shortcut. Strictly speaking, I would say select and then list out all of the fields within the customer table. That's a little bit more of the equivalent, but select star is a shortcut. Now, if you compare these two expressions, the link expression and the SQL statement, you can see that they have the same basic parts. A select clause to indicate which field to return, a from clause to indicate where the data is coming from, here the customer's collection or the customer table, and a where clause to filter the results. In both cases, you'll get all the fields of the underlying object or table that match the filter condition. Now, obviously, or probably as obvious, the language teams, C# and Visual Basic, used SQL as a model for link query expressions, but turned around the order of the clauses mainly by putting the select clause last rather than first as you do within SQL. And the reason is very simple: IntelliSense. By putting the from clause first, Visual Studio has the information it needs to retrieve information, metadata, about the object schema as you type, and then provides IntelliSense guidance as you continue to type the expression. If the select clause were first, Visual Studio would have no clue about what object you wanted to query and would have no way to provide the help as you type. And in fact, this is a major reason why Microsoft has had such a hard time providing IntelliSense for T-SQL in SQL Server Management Studio. It's there, but it just doesn't work all that great because it's dealing with the select clause first, and so it needs a lot more information before it's able to help you along. The current implementation just doesn't work all that well, and many people just turn it off. But happily, with each new version of Management Studio, Microsoft seems to be refining it. And there are third-party tools like that from Redgate as well that you can use that are a big improvement on that within Management Studio. All right, so anyway, the changes in Link are geared towards making it easier for you to write this code. Because keep in mind that first statement there, the from C and customers, actually is built into VB and C#. Okay, then the other technique you can use is link methods. When the .NET language compiler encounters a link query expression, that previous example I showed you, the first thing it does is to convert the from, where, order by, select, and other language keywords to more traditional methods on an object that contains the data that you want to query. Because behind the scenes, these are all objects, and code works with properties and methods. Okay, so the main reason for this is that although the language compilers understand the link expression and its keywords, again that previous syntax that I just showed you, the CLR, the Common Language Runtime, doesn't understand those keywords. The CLR really only understands how to execute methods. So as a result, each of the link keywords has an associated method. So the link expression that I showed you previously is translated to something that looks like this. Customers.where, because the where clause becomes a method call on that customer's collection. And then it provides a lambda expression for the predicate, for the where expression. Now, this isn't quite the actual result of the conversion that happens behind the scenes, but it's close enough for our purposes here. There's some other things that go on that really aren't relevant to the discussion here. Okay, now, the argument to that where clause is a lambda expression, and that's used to provide the filtering condition. A lambda expression is just an inline anonymous method that provides access to the customer object, in this example here, and its properties within the link expression. It's a very powerful language feature that has many uses, but in this course I'm going to keep them fairly simple for this kind of example. So all that's going on is that it's defining the control variable of C, and then it uses C to represent each of the objects that are in that collection, and then provides the same properties of the object. In this case, they're all customer objects. Gives you access to the first name property so that you can filter on that condition here by comparing it to the literal string and. And there's lots of different ways you can implement where clauses for just about any kind of condition that you want to filter the underlying customers on. So if you're not familiar with Lambda expressions, just get used to them. Somewhat ironically, I prefer the C# format that I'm showing you here, the C# syntax. The VB syntax is a little bit more verbose, but it's doing the exact same thing. Again, providing an anonymous method that is being executed essentially on each of the objects within that collection. All right, so what's happening here is it uses the methods directly instead of using the query expression syntax and having the compiler generate the methods for you. One of the benefits of using the method syntax is that you can chain methods together, and you'll see some examples of that. So if I have an order by clause, I can say customers.where, whatever the parameter is to the where clause, dot order by in order to sort them, and then provide another Lambda expression to identify the field that I want to sort them on. And so you can string these out, and it's very efficient to code. And you get full IntelliSense support as you're writing the code within the code editor within Visual Studio. All right, let's take a look at executing a few queries here within LinkPad. So here's one example that I showed you. So this is a query expression. Same expression as I showed you in the slides, from C in customers, where C.firstname is equal to Ann. And then I select C, indicating that I want to select the entire customer object. And when I execute that, we get an error. Selection, type or namespace, name infrastructure, does not exist in this namespace. Validation. Okay, something isn't quite right here. I'm not quite sure why I have 2 here. Let me get rid of that. I'm not sure why that is appearing. Delete that connection. Now we only have 1 connection. And I'll try to execute it one more time. And there it executes. Okay, I don't know where that second connection came from. I didn't create it. Maybe I didn't save something correctly, or maybe I just found a bug in LinkPad. But anyway, easily corrected. All right, so there's the results of that expression. And once again, I get all of the 6 customers within the database whose first name is Ann. So that's the query expression form. And there's that equivalent SQL statement. And here is the method equivalent of that statement. So I'm just using the customer's property of that AWLT's entities context object and using the where method and this Lambda expression. And I should get the exact same results. And it looks like I get 6 items. I get a DB query of customer, scroll through, and if I compared the data, I would see that I in fact got the same results for both of these because these are exactly equivalent. So keep in mind, if I were to use this code within a C# application, the compiler would essentially compile it to this code here. Again, not precisely, there's some additional IL stuff that's happening, but this is essentially what's happening. But I can write this code directly as well. Okay, so let's make it a little bit more complex now and show this chaining. So I once again want all of the customers where the first name is Ann, but I want to order them by company name. And rather than returning all of the properties, I just want to retrieve the company name property here. So I'm using the select method. It's the equivalent of the select statement, but I'm using this Lambda expression in order to just retrieve the company name rather than all of the fields within the table. So I'll select that and execute it, and there you have all of the company names that have contacts with the first name of Ann. Now, this is one thing that you'll see anytime you use AdventureWorks LT. There is duplicate data within the customers table. It's not exactly the cleanest data that you'll ever see. But I'm sure Microsoft had a purpose for that, maybe to show how to clean up data. So anyway, so we have all 6 records again, same 6 items, just showing the company name. And as you can see, we have 2 rows for each of the company names. And that's actual duplicate rows within the underlying customer table in the database. All right, so once again, to emphasize, the C here is just a control variable that gives you access to each of the individual customer items that are returned by this customer's object. And as you can see, LinkPad has a little bit of IntelliSense here. Unfortunately, the syntax checking, the red squigglies there, aren't quite right. In fact, because I'm using C# expressions here, if I were to include a semicolon there, as it's saying, then it wouldn't execute. If I change to C# statements, then I can include the semicolon. All right, so again, this C, it's a control character. You're not limited to single characters, but for the most part, they're going to represent a customer. You could write out customer lowercase here and use that, and that'd be perfectly legitimate. Then you'd have to write out customer.firstname and order by. Here, if I used customer, I would use customer as well. But see, generally the convention is to just use the first letter of the underlying object type. That's not required by any stretch. Here it's customer. If I was writing code against order, I'd probably use O. The other thing is that you're not required to use C, the same control variable name, throughout an expression. This lambda expression within this where method is entirely independent of this lambda expression within the order by method. So you can call these different names within different method calls, and that's exactly what I do here. I call it C here. So because I use C right there, I need to use C with it throughout this lambda expression, how long and complicated it might be. Here I use D, and then I need to use D to reference it. If I use C here, I'd get a compile error because it doesn't know what C is. And here I used E. And if I execute this code, you'll see that I get the exact same results. No difference whatsoever. This is the exact same statement here because these control characters in each of the individual methods are entirely different from the other ones. Now, when you chain methods together like this, Link evaluates the methods one at a time. So in this particular query here, same thing for this query there, they are the same query. What's happening here is it first evaluates customers. It uses that property to get a reference to that DBSet collection. And then the where method is next. It evaluates this and filters them on that predicate. And then the order by, so it sorts everything that made it through this filter. It's then going to sort by the company name. And then finally the select method then selects just a single property from, in this particular case, from each of the customers that are returned by the order by method. So they're now in sorted order, and it just retrieves just that company name. So each method in the chain operates on what was returned by the previous method. So order by operates on what was returned by the where method, and select operates on what was returned by the order by method. And this is all for the purpose of building the query that Entity Framework will send to the database. It doesn't mean that there's going to be a database query for each method in the chain. That would be a mess. That would be a performance nightmare if it did that. So essentially what's happening is that it's using all of this to build a SQL statement in order to execute it against the database and retrieve that customer's data. So the end result is that there's a single SQL statement sent to the SQL Server database. And if I want to see that, I can execute this code here, see the results, and then look at the SQL. And so you can see it's using the alias name of extent, so it's selecting company name. So it got this from the select method to just retrieve the single property. It got this from the customer's object name right there. And then the where clause it built from this where method using that lambda expression. So this is the actual SQL statement that Entity Framework built and sent to the database. All right, so those are the two different syntaxes that you can write LINQ expressions in. And that doesn't actually apply just to LINQ to entities. This is true of LINQ in general. So that begs the question, which syntax should you use? Well, the real answer, really the only answer, is that the LINQ syntax that you use is entirely a personal choice. There's no functional difference between the two, except that the query expression syntax doesn't support all possible LINQ features, just most of them. Now, in this course, I'm going to use the LINQ methods syntax, mainly because I prefer its syntax and because it exposes the full range of LINQ features. I've also found that it's easiest to learn and use just one syntax, rather than using LINQ expressions most of the time, and fumbling with the code when I need to use LINQ methods to take advantage of some LINQ features that aren't exposed by LINQ expressions, or vice versa. Another benefit is that if you switch often between using C# and Visual Basic, the differences in the LINQ method syntax between the two languages are quite small compared to the syntax of query expressions, other than the syntax of the lambda expressions. The lambda expressions are just flat out different, and you just need to learn them in the two different languages and get used to the differences. Now, translating between the two LINQ syntaxes can be a bit tricky because of the lambda expressions. But once you have a feel for the syntax, LINQ methods just feels more natural, at least it does to me. But which one you use for everyday programming work is entirely up to you.